Okay, so welcome back to lecture once again, guys. Now, we talked about a lot of things in terms of a theory. Now it's time for doing a practical, and with the help of a practical data. So I'm going to talk about all of these things. So whether it's a mean, median, mode, skewness, IQR, histogram, bar plot, box plot, pie chart, line chart, pair plot, heat map, each and everything. And then I'm going to give you a definition of the exact same thing. So let me start basically with code. So here I'm just using a Jupyter notebook. You can try to use a Jupyter notebook wherever you want, maybe in a Google Colab or maybe over here. And plotting library wise, I'm going to use a Seaborn in this particular place and matplotlib. Yeah, so pandas numpy is a common one for me, which I'm going to use. So first of all, try to do a import. So import import and import Seaborn as SNS. It's not able to identify my code. Okay, it's a markdown, right? Let me convert that into a Python code. So import Seaborn as SNS, yeah. So, and then import pandas, again not identifying automatically. So I'll just restart. It will be fixed, yeah. So import pandas, yeah, now it's working. Pandas as PD, fine. And then import numpy as np. So this is another import matplotlib dot pyplot as plt. So all the required import we are trying to do, fine. So matplotlib, and then from scipy basically dot stats. So try to import skew and a mode. So these are the imports that we are going to use. So all this import. Now the very first part is that we have to load a data set, right? So we need some sort of a data so that I will be able to show you all of these operations. So there are a lot of inbuilt data set inside these libraries you will be able to find out. So one of those data set is called as tips data set. So you go to hotel, you give a tips to a waiter and everyone. So after finishing your lunch or dinner, so this data set talks about that particular tips, and around tips it is going to build the story. So I'm going to use that data set sns dot load dataset, and load dataset wise I'm going to use a tips dataset, so tips, which is already available inside my Seaborn library. So you don't have to do anything, you just have to do the load, and it is going to give you the data. As you can see, it is going to give me the data. Now in this data set, if I have to talk about this data set a little bit, so total bill, so the amount of the bill is given, a tip is given. So for this amount, so someone has paid this much of tip, sex, whether it's a female or whether it's a male. Smoker, no means no smoker, yes means smoker, yeah. Day, so which day? Sunday, Monday, Tuesday, Wednesday. Time, so dinner time, lunch time, supper time, whatever it is. Size, so maybe like a pack basically, so how many people went out there. So this data set talks about this entire things, yes. And this data set I'm going to use to show you all of these things which I have mentioned over here. So one by one, so I'm going to show you each and everything in a sequence, in a series, you can say. So here, first of all, if I have to calculate like a mean, let's suppose, yes. So if I have to calculate the mean, so what is the total or what is the average bills that this restaurant or that is available inside this particular data set? What was the average bills, or what was the average tip? Yeah. So because both make sense in terms of finding out the statistics. So what is the average bill, or what is the average tips which has been paid in this particular restaurant or as per this particular data set? I can do it. So what I can do is that first of all, I'm going to check what is the type of this tips data set. So types is basically data frame. Data frame simply means that data is already available in a pandas data frame, and pandas like operation I will be able to perform in a easiest possible way. So first of all, from this tips data set or data frame precisely, so let's try to extract a total bill. So let's try to extract basically a total underscore bill. Yeah. So total bill. Now this total bill is this one. So this is the total bill column. Yeah. And if I have to find out the average of this data, it's very simple. I will be able to find out. So total bill dot, if I'm going to call mean over here, so it is going to give me like a 19.7859. So technically it's a average of the bill. Similarly, so for this total bill, if I have to find out a median, right, median, or not just for this one, I can try to find out for anything, but I'm just showing you that, okay, fine. So how you will be able to do a mean, median, mode kind of a calculation for a particular data set. Yeah. So total bill dot median. So my median value is basically 17.795. Yes. So this is how I can try to use a median function directly, and I can try to do the math. Now, if I have to calculate a mode, so total bill dot mode, I can try to basically call over here, and I will be able to get a result. So on a 0th position, it's giving me 13. So 13.42 is a mode. I believe 13.2 has appeared multiple times over here. I'm not sure about it. I'll have to look into the data set first. Yeah, but yes, I can try to find out the mode over here. As simple as that. Now, if I have to find out the skewness into a data, a skewness value into a data, so I can try to use a skew directly in this particular column. So whether we have a skewness into this bill that we have, so I can try to just call a skew, and skewness is equals to 1.12. This is something that we are able to observe. Now, what does this means by that? So if you remember from my skewness class, so I have shown you a skewness calculation, right? So this was the class where I have shown you the skewness calculation. This sheet is also shared with all of you. So this was the formula, n by n minus 1 into n minus 2 summation of data minus mean divided by a standard deviation to the power 3. And here, so if skewness is equals to 0, if this formula is going to give you 0, it simply means that there is no skewness. If it is going to give you something negative, it simply means that there is a skewness. And if it is going to give you like a something positive, it again means that there is a positive or right hand side skewness. So we are already aware about it. I'm just trying to calculate with the help of program. So here we are able to get 1.126. It simply means that I have a skewness into my data set on a higher side. Means there are some bills which is like having a very high values which was paid. Again, after plot, you will be able to find out more and more. But this is the conclusion which I will be able to draw out of this one, that there are some bills which was very high. Simple. So this is what it is trying to represent. And this is something which we have already discussed in my past, right? In my past, if you remember. Now, so we talked about even a IQR, interquartile range. And we were able to do a calculation, a Q1 we were able to calculate, a Q2 we were able to calculate, Q3 we were able to calculate, and interquartile range is nothing but Q3 minus Q1, right? And based on that, we were able to calculate what will be the value for a lower bound, what will be the value for a upper bound. If value is lesser than this, then outlier. If value is more than this, then again outlier. All this story we have already discussed. Now, even with the help of programming, because programming is going to give you a power to do a calculation with a millions of a data. And this is what we are trying to do, right? This is what we are trying to prove over here. So with the help of that, right, with the help of that, you will be able to do a math, you will be able to do a calculation. So here, if I have to calculate a Q1 for this total bill data set, right, a Q1 for this total bill data set. So total bill dot, I can try to call a quantile, and I can say that, okay, so for just 25th percentile, right? So this is going to give me basically a Q1. So if I'm going to like print it, so my Q1 is basically 13.34, and similar kind of a calculation we have done over here, right? We have done over here. So basically my Q1 is nothing but on my right hand side, whatever data is there, right? So whatever data was there, I'm just trying to find out like a median of it, and then divided median of it. I'm just trying to find out, nothing much. Yeah. So this is something which I'm trying to find out. And then here the median is median for the entire data. So basically Q2 is nothing but a median. So if I'm going to call that, what is my Q2? If I have to call what is my Q2, so total bill dot median. So I can just write like call median, and this is going to my Q2, by the way. Yes, this is going to my Q2. Fine. So my Q2 is 17. My Q1 is basically Q1 is 13.34. Similarly, I can try to calculate my Q3. So what could be my Q3, by the way? So my Q3 is going to be total bills, not timeout. So total bills dot quantiles I can try to call and just give a 0.75th percentile. So this is going to be my Q3. So my Q3 is what? My Q3 is basically 24.12. Yes, my Q3 is going to be 24.12. And if I have to find out IQR, it's very simple. My Q3 minus my Q1, and that is going to be the IQR basically, right? That is going to be the IQR. So my IQR is what? My IQR interquartile range is 10.77. So in this particular fluctuation, 50% of the data is going to leave. Yeah. If I have to calculate a lower bound, if I have to calculate an upper bound, I can do the math even for that one. Yes, I can do the math even for that particular one. So based on this formula, a same formula that I have used. So my lower bound is basically Q1 minus 1.5 times IQR. So if I have to calculate lower bound, so my lower bound is what? So my lower bound is what? So this formula, just try to apply Q1 minus 1.5 times IQR. So here Q1 minus 1.5 times into, you can say, and IQR. So this is going to give me the lower bound. So what is my lower bound? So my lower bound is minus 2.822. So if there is some data below this one, there is an outlier. What is my upper bound? What is my upper bound? So my upper bound is nothing but Q3 plus 1.5 times basically IQR. Yeah. So upper bound, what is the value? So my upper bound is basically 40.29. So any data above this one is going to be treated as a outlier, and any data below this one will be treated as an outlier. That's the meaning of my upper bound, and that's the meaning of the lower bound. So whatever we have discussed, yes, seamlessly we are able to do a math, we are able to do a calculation over here, as simple as that. Now, so let's try to do some sort of a plotting over here, and with the help of plotting, let's try to understand a couple of more things in our next lecture. So with that, thank you so much everyone, take care, and see you again in my upcoming lecture.